Ladies and gentlemen, my name is Qinghan Lai. I come from Qilu University of Technology, Shandong Academic of Science. Our paper title is a Chinese multi-modal relation extraction model for Internet Security Offense. I'm glad to introduce our work on DSN 2022 and AITS Workshop 2022. In Internet security offense, it is essential to extract the relation from Internet financial text. Its purpose is to automatically extract the entity relation from a Chinese financial text with given entities. However, the existing Chinese relation extraction models have the following three problems. Firstly, Chinese is an ancient pictograph language, and the current relation extraction models ignore the promotion of pictograph information on Chinese relation extraction. Secondly, the pictographic semantics of Chinese naturally contains some impact substantive means. Therefore, the fusion of pictograph information is helpful to solve the semantic ambiguity of text. At present, the fusion of pictograph semantic and text semantic is also a key problem in the field of Chinese relation extraction. Existing Chinese relation extraction models lack effective fusion methods and research on Internet financial security. To effectively extract the pictographic semantics of Chinese characters, we design a novel Chinese character pictographic semantics extraction method, which includes shape and structure semantic extraction, named CMRE. Furthermore, to obtain better fused semantics, we design a novel multi-modal fusion module by introducing target and auxiliary attention into transformer. Considering the interaction between different semantics, besides, we fuse the Chinese pictographic semantics with text semantics and applied them to the Chinese relation extraction for the first time. In general, our module extracts text semantics, Chinese character shape, and structure semantics for fusion and extract of relation. In the text semantic extraction module, we use MG lattice as the core of text semantic extraction module, which can effectively deal with Chinese ambiguity. For Chinese pictographic information, we design semantic extraction module of Chinese character shape and structure, filtered some useless features through a dynamic semantic selector, and then obtain the fused semantic through the target and auxiliary semantic fusion module. Finally, we aggregated sentence context information for relation classification by an attention lawyer. Chinese is a kind of pictographic language. So ancient pictographic language contains more specific pictographic information. After thousands of years, Chinese character has evolved from per pictograph to simplified characters. Every Chinese character changes evolved lost part of the pictographic information to a certain extent. So, in order to effectively mention taking the pictographic information of each character, we choose 6 Chinese fonts. We use 6 Chinese fonts and pure game to generate single-channel Chinese character images for each font. When extracting Chinese shape semantics from Chinese character images, Chinese shape semantic mostly exists as an edge where Chinese character intersect with the background. which tend to be a local semantic feature. Compared with sheep semantics, the pictographic information of Chinese characters lies more in its pictographic structure, such as Chinese radical and word structures. Moreover, pictographic semantics can be understood as a global semantic feature, which can be better reflect the whole structure semantics of Chinese characters. However, merely marking the pictographic structure of Chinese characters will consume huge labor and time cost. Therefore, it's very challenging to extract Chinese structure information. So we propose a automatical method to extract the structure information of Chinese characters. This is the algorithm description of Chinese character graph generation. The hyperpixel segmentation algorithm and Qinghan are used to establish the connecting edges of the hyperpixel points, and the edge with less than 0.5 are flattened out. The structure of Chinese characters obtained is shown in the part 3 in the figure. In the shape semantic extraction module, we treat each font image of Chinese character as a channel. That is to say, each Chinese character has 6 channels of image. Then we use 5-layer scene and BILSTM to extract its semantic information. The dimension settings in CN are shown in the figure. In order to extract Chinese structure semantic information, we design a Chinese structure semantic extraction module. Different pictographic structures of Chinese characters have a certain similarity. That is, some pictographic structure contain certain semantic information. For structure semantic extraction, we use graph neural network to extract structure features of Chinese characters. However, the traditional graph neural network has the disadvantage of being over-smoothing, which results in poor ability to distinguish extracted Chinese structure. Therefore, we introduced the Principal Neighborhood Aggregation Network (PNA) to extract the structure features of Chinese characters. Using the degree-based Scala and forecast operators, the PNA theoretically solves the oversmoothing problem of graph neural network, which has excellent performance in a variety of graph texts. After that, each image is read out by attention, and a single vector was obtained by concatenating the features of multi-modal multi-font structure, which was input into BILTM to extract structure semantics. Compared with pre-trained text semantics, shape semantics and structure semantics contain fewer features. Therefore, direct static information fields may produce noisy. Pay attention. In different Chinese sentences, the influence of the pictograph on relation mainly extends in a few Chinese characters, and not all the pictographic information of Chinese characters in the sentence can promote the relation. So we propose to dynamically select some useful pictographic semantic information as auxiliary information to optimize the distribution of text semantic information during the training model. We use a layer of MLP and sync mode activation function to dynamically select semantics with probability greater than 0.5 for subsequent fuse operations. In the fusion, we take the text semantic as the target semantic and the pictographic semantic as the auxiliary semantic and design the corresponding multi-modal semantic fusion module. We concatenate the shape and structure semantics extracted by the encoder to obtain pictographic semantics. In the decoder module, we get fine-tuned semantic information through semantic interaction using the target and auxiliary attention mechanism. For fusion semantics, we use an attention mechanism to aggregate the sentence context information for relation extraction. In the experiments, we use 7 and financial IE datasets for the text of Chinese relation extraction. Among them, the 7 datasets belong to literature field dataset, and the relation contained is impact, and the prediction of relation need to be based on a certain reasoning ability. Financial IE is a dataset in the financial field, and most of the relations are related to business logical. The information of this set is shown in the table. In the Chinese relation extraction text, as in mainstream research, we evaluate relation extraction results using the FE value of relation prediction. In addition, in order to evaluate the model results more comprehensively, we introduced the ROC curve and adapted the L and curve to evaluate the model results. To comprehensively evaluate our model, we select the classical model in the field of Chinese relation extraction in recent years as a baseline model for experimental comparison. The results of comparison experiments are shown in Table 1, and as can be seen from the table, the Chinese semantic extracted by the model with a simple structure, such as BRSTM, attention mechanism, and CN, are limited and cannot handle the Chinese relation extraction text well. Although M-feature tries to fuse multi-modal semantic information of entities and apply the various model structure in extraction process, the way of directly splicing semantics cannot effectively fuse semantic information. In contrast, FGGRM and lattice consider the interactivity of semantics in the fusion process, thereby improving the performance of Chinese relation extraction. In addition, although both provides rich semantics, lattice use harness pre-trained word vectors, so the introduction of BERT does not improve relation extraction much. MG lattice as the current model for Chinese relation extraction performs well in both datasets. The model proposed in this paper uses MG lattice as a core module of text semantic extraction to extract text semantics, thus ensuring the validity of extracted text semantics. Besides, the target and auxiliary semantic of Chinese text, shape, and structure semantics are integrated through transformer, and the interaction between semantics is considered. Those improvements enable our model to achieve the best results on both datasets. Additionally, we believe that the financial text in financial IE dataset contain many fixed entities, such as company, shares. The introduction of pictographic information improves the ability of relation extraction by marking the repetitions of those specific words with pictographic semantics. The figure above shows the experimental results of ablation experiment. We found that by direct splicing fields of extracted Chinese character shape structures and structure semantics does not improve the results of relation extraction. In contrast, to a certain extent, direct concatenation will bring noise, which reduces the effect of relation extraction. The results of MG lattice and fusion show that the strong ability of transformer to extract semantic information. This reflects that aiding the target and auxiliary semantic fusion module on the basis of MG lattice can improve the model relation extraction ability. We found that shape semantic and structure semantic are not real noisy, but need to perform interactive fields between multi-modal semantic through the target and auxiliary semantic fusion module to learn better semantic feature distribution. On the other hand, we can conclude that the pictographic semantic information of Chinese characters is not as rich as the text semantics. So, trying to get better semantic feature representation will require consideration of appreciate semantic fusion methods. According to the experimental results, we can find that the semantic interaction fields between the multimodal semantic of Chinese characters is of greater significance for downstream Chinese relation extraction texts. As shown in the table 2, we also set three different dropout values. The experimental results show that the relation extraction result is best with dropout as 0.5. To summarize our work, we propose a novel Chinese multi-modal relation extraction model which applies Chinese pictographic semantics to the Chinese relation extraction for the first time. We improve the methods to obtain the shape and structure semantics of Chinese characters. Furthermore, based on transformer, we design a new multimodal semantic fusion module by introducing the target and auxiliary attention mechanism, which can better learn the interactive features of text and pictographic semantics and improve the relation extraction ability of CMRE. The experiment's results show that the effective CMRE in relation extraction. In the future, we will introduce the idea of pre-training to optimize the Chinese relation extraction model. We will attempt to pre-train the language models based on Chinese pictographic semantics, including local shape semantics and global structure semantics. In addition, efforts will be made to improve the semantic universality of Chinese pictographs so that they can be widely used in other Chinese natural language processing texts. In addition, text information in the field of Internet security or finance requires high logical reasoning ability. Therefore, we will focus on the field of Internet security or finance and try to introduce a knowledge reasoning method to improve the reasoning ability of Internet security or finance text information. Our report is over. Thanks.